The mass of this is 44. So we can say that 44 grams. Here we have a 2 times 84 grams of hydrogen, sodium hydrogen triisocarbonate 4. So now, but in the reaction, in this reaction now, the reaction will produce the 33. That means 33 grams. So how do we do this? We know that from this balance equation, the one given to us, we know this was here. We know that 44 grams will require, let me convert this. This will give us, let me convert it, 84 times 84 times 2 will give us, let's go by this, grams. That means 44 grams will give us 168 grams of what? We require 168 grams of what? Sodium hydrogen triisocarbonate. So in that case, what we mean is that 44 grams of carbon. In this question, we are going to learn how to calculate um, chemistry related problems that has to do with mass to mass stoichiometry. That's the relationship that has to do with mass to mass. This question says that if you look at this question, in a stoichiometric equation, we talk about the chemical equation. In chemical equation, it gives us all the basic information about a particular reaction and the masses that involve both the product and the mass. From the relationship, the moles, we will be able to calculate each of the reactants, the mass of the reactants, mole of the reactants, both that of the products from a balanced chemical equation. And that's what we're going to be learning from here. That's why I want you to pay attention, watch to the end, and see how you can handle related problems in chemistry calculation. In this question, we're going to be looking at, he said that in order to determine the percentage of sodium hydrogen triisocarbonate in a brand of baking powder, 20 gram of the sample was heated to constant mass to produce 3.3 gram of carbon 4 according to the balance equation. That's the balance equation we have here. It says calculate the mass of the sodium hydrogen triisocarbonate in 20 gram of the sample and percentage of the sodium hydrogen triisocarbonate in the sample. That's what we're going to be looking at now. From this balanced chemical equation, there are things we can find out. Just watch as we go through it together. We have okay, looking at this is a product. There's a relationship. We look at the relationship that is here. Now we're looking at the mass of, we want to find the mass of sodium hydrogen triisocarbonate, and we are given the mass of carbon 4 produced, which is 33 grams. From this balance equation, we notice that when we have 2 moles of sodium hydrogen triisocarbonate, we will get a mole of carbon 4 gas. So in this case, what it simply means that from this balance equation, we know that molar mass of sodium hydrogen triisocarbonate is 84 times 2. That is what we need in this reaction for this reaction to be valid. This is the molar mass and the number of moles. We give us the word reacting mass. We have the reacting mass here, which is 2 times 84, the molar mass. Now, how do we get the molar mass? We know that this one is 23, 1, 12, and 16. 16 times 3 will give us 48 plus 12 plus 1 plus this will have 84. So that's how we got that. Now, the next thing we are comparing the two masses. The mass again we have here is the molar mass of this is 44. So we can say that 44 grams. Here we have a 2 times 84 grams of sodium hydrogen triisocarbonate 4. So now, but in this reaction now, the reaction will produce the 33. That means 33 grams. So how do we do this? We know that from this balance equation, the one given to us, we know this was here. We know that 44 grams will require, let me convert this. This will give us, let me convert it. 84 times 84 times 2 will give us, let's go by this, grams. That means 44 grams will give us 168 grams of what? We require 168 grams of what? Sodium hydrogen triisocarbonate. So in that case, what it means that 44 grams of carbon 4 will give us, we require 168 grams of sodium hydrogen triisocarbonate 4. So now what will 3.3 grams require? So what we have here will be, to give us 168 over 44 times 33 over 1. So going by this, by what we have here, will be times 3.3 divided by 44. So what we have will be 12.6 grams. That is 12.6 grams of sodium hydrogen triisocarbonate 4 will be giving us 33 grams of carbon 4. So now the next thing we are going to find out, what it simply means here is that in this 20 grams, the mass of sodium hydrogen triisocarbonate 4 there is 12.6 grams. So now you say that calculate the percentage of sodium hydrogen triisocarbonate 4. To calculate the percentage of that, what we are going to do is to, you know that this is the mass of sodium sodium hydrogen triisocarbonate 4. Now the total mass of the sample is 20 grams. That means to get the percentage, that will be 12.6 over what? 20 times 100 over 1. So what do we have here? Times 100 divided by 20. The percentage of that is what? 63%. Thank you so much for being part of the class, and we want to encourage you to subscribe if you have not subscribed, like and share. If you have any question, feel free to ask your question in the comment section. I will always attend to you. Thank you.